Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard other type puzzle. And it's basically Masyu with some weird colorization stuff going on. Anyways, let's get to the rules. We have standard Masyu rules apply, which means draw a non-intersecting loop through the centers of some orthogonally connected cells that passes through every pearl, which is, I believe, a circle. So it's a non-intersecting loop through some orthogonally connected cells. So that means it goes only through edges. It does not go diagonally. So it does not go diagonally. And the loop must pass through every pearl, which is a circle. And the loop must turn on black pearls. So it turns on black pearls and it goes straight through the cells on either side. So that means entering a black circle, it must turn in that black circle or black pearl. And the cells on either side that it turns into must go at least one cell through that next cell. And then it can do whatever it wants after it goes straight through the cell next to the black pearl. The loop must go straight through white pearls and turn in at least one of the cells on either side. So it must go straight through on a white pearl, and then in one of the cells, at least, it must turn outside of the white pearl. Each pearl must be assigned a color from red, green, or blue, RG or B. Pearls divide the loop into segments, and each segment has a color equivalent to the combination of the colors of the pearl on its endpoint. So each pearl must be assigned a color from red, green, or blue. I don't know how many pearls we have. And each pearl divides the loop into segments where each segment has a color equivalent to the combination of colors of the pearls on its endpoints. So colors are combined as follows. Red and red gives you red, blue and blue gives you blue, green and green gives you green, red and green gives you yellow, red and blue gives you magenta, and green and blue gives you cyan. So all square labels must be visited by a segment that matches its color. And a segment may visit more than one label, provided each label along the segment is valid. And not all segments must visit a label. So some squares will have box labels on them. And that box label must be visited by a segment that matches its color. So again, if the endpoints are like, for example, red and green, that would give you a yellow segment, and that yellow segment must visit a yellow label must be visited by a yellow segment. And again, a segment can visit more than one label, provided each label along the segment is valid. So it just has to be matching the color, but not all segments must visit a label. I is earwish and represents a different color each time it appears. Okay. So that means, I guess, I don't know how many eyes there are. There might be 6 eyes, I guess. And then they must be a different color, I guess. Okay. And for solution check to trigger, the loop must be drawn in green. And each pearl must be shaded either red, blue, or green. How many eyes are there? Oops. There are 1, 2, 3, 4, 5. Yeah, there are 6 eyes. So each one has to be a different color, but we don't know which colors each. And for the line, we have to be green. So again, for Masyu colors, for black cell, it must basically, there must be one cell going in, and it has to be extended for essentially one cell at least after the black cell. It must turn in the black pearl, but the cells outside of the black pearl have to basically extend. And that's how black pearls work. White pearls, you have to go cross through the white pearls, and it must turn in one of the cells at least after it goes straight through the white pearl. And each pearl, again, must be red, green, or blue. Okay. Oh, and the title of this puzzle is Apochromat by Dumadiat. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's see if we hide. So this is magenta. So we know there has to be a line going through this. Same with this. This has to have a line going through this. This must turn on black, so it must go straight through. So it goes straight through the white, which means it must go straight through there. And then it turns. Okay. White has to go straight through on the boundary. So this is white and this is white. This is white. This is white. This has to go straight through, so it could be either that way or that way. We're not sure. Okay, white has to go straight through. Okay, magenta is blue and red. Okay. um. Hmm. Hmm. Okay. How do we color this? Well, this is either going straight through, or it's turning here, and then this would turn here. This is interesting. So this has to turn. So say we actually go from here to here. So say we turned on here. So say it went that way. It has to go straight through. This has to go straight through. And then this cell could not go straight through either of the directions. Right? And then if it's the same way this way. If this goes straight through, that goes straight through, that blocks this from going straight through either way. So this cannot be going this way. It has to be going that way. So it goes straight through here. It goes straight through here. Which means this cannot go straight through this way. It could actually. Never mind. It could go straight through and then turn. That is possible. This cannot go straight through this way because then that would be considered branching. So this has to go straight through there. And then it either goes this way or it goes this way. Either way, it would block the magenta. Oh, that's interesting. So if it goes this way here, this has to be essentially going that way, and then this would form a set. This would have to connect to here. This would have to connect to here. So it would form that set. But if it goes this way through, it's the same thing, right? Oops. It would have to. This would have to connect. This would have to connect. Go that way. This would have to connect that way. So either way, this has to be a. These two digits have to be ones that form blue and red. So these are blue or red. Oops. Oops. I'm making it gray. Okay, I don't know how to use these. So this is blue or red in some combination, right? And the yellow has to be red and green. So this is definitely green here. So that's definitely green. We actually don't know which ones these are. Let's undo those. We definitely know this is green, though. So this is cyan. So we know this is specifically green. And this is some blue-red combination, but we don't know which. Obviously. This cyan has to be, it's blue and green, I believe, right? So either it goes this way. It has to turn in one of these, so but it could just turn there. We have blue going here and green being here. Interesting. That means the ones that they have to go through. What are the ones that they have to go through? Say the green does not go through here. That means the green would have to go through this direction because it couldn't go that way. Then it would go straight through. And how does that work? This can never enter except going that way. Yeah, the problem is these are distinctly two different colors, green and blue, and they don't share anything there. So you can't have green going this way. I think you have to have green going this way here. And then it must exit through green. This then has to go through blue. You could have green going around here and then blue going... So can you have blue going that way? If that's the case... So say we tried to have this go turn here, go straight through there. I don't think that works. right? Because if we try to do that, um, how does the blue get out? Well, first of all, blue has to go here. If that's the case this way, this can't turn in this way. Because this has to get out and this has to, well, this has to get out, but it has to collect the blue on the way. And this has to get out, but it has to collect the green on the way. The loop cannot branch, so you can't intersect itself, right? Not intersecting, right? So yeah, if we try to go through this way, that's not going to work. Because one of these, so this line, I think, has to come in. If this does not come in this way, so say it exited out this way, the only cells that can go through circles here is 1, 2, and 3. But the problem with that is that you have to have 2 of the circles be blue and 2 of the circles be green. That requires 4 circles you have to go through. So therefore, this must definitely go that way. That means this cannot turn in here. This has to go in. If we turn in there, this has to go straight out here. And then this would be blue, which would be connecting with blue, but the loop would be way too small and it would not connect to the rest. So this cannot connect this way. This has to go that way. Since this goes that way, this could connect. Well, okay, if we go down here, then the problem is... Actually, that could work. You have blue going here, blue, blue going there. What happens if we go this way? That means this must be blue going through here, and then going there, and then this would be green going through there. So either of these could work. So we know this is definitely part. So if it goes down, then this is green and green, right? If it doesn't go down, that means it goes this way. This must be blue connecting to here, because it can't reach green and then block through here. So okay, what are the combinations again? If we go this way, this has to be green and green, and this is blue and blue. So in this case, we'd have green and green and blue and blue that way. Okay. If we had going this, oops. If we had the line going this way, what would these be? This could not connect here because, again, we need them going through the labels. So this would definitely be, this is green definitely either way, and then this is blue or green, and this would be blue both times. Okay, so we know this is definitely green here. And this must be blue here. We're definitely certain of that. But we don't know how these work. So this could be blue or green. This could be blue or green, depending on how it turns. Either way, this line has to go straight through here. Right? If it's line there, it has to go line there. That means this has to turn here, which means this turns here. So this is into yellow, which is green and red, I believe. Yep. So this is green or red. Though we know this can't connect to, well, actually, it could connect to one of these. So obviously, if it goes down here, it can't connect to any of these. So it has to connect through to here. So it would have to be connecting that way, or through the eye, essentially, in some way. Which could be green and green, technically. If it goes straight, how does that work? Then this would have to be red. This would be blue. So this would go straight that way. It would turn here, turn here. So green and red, that would be blue. This has to connect to something. Cannot connect to this end, it has to connect to here. Interesting. Cyan is green and blue, so this could connect here. Um, um, okay. This could obviously just connect that way. Blue cannot, it cannot go to blue, so this has to turn either here or turn here into the yellow. This obviously cannot. Cyan is a combo of blue and green, right? Yeah. So this would, if it can't go here, then here for red, then green. So this is either going straight through here and then turning to the red, or going straight through here, turning to the yellow. It cannot turn there. It could turn this way. And that would be the case if this is... So cyan and yellow both contain green. So therefore this would be green. Green and red. So this would force that to be red there, if that's the case. Okay. This must go through cyan or magenta. We don't... Oh, this has to turn because this goes straight through. So this must turn here. That's cyan. Cyan is blue and green. So we have blue or green here. We have blue or green on this line. Should I be drawing that? Maybe. It's I don't know. It's easier for me to see that visually and go, oh, okay, this has to be one of those two. If it goes this way, this would obviously be green. So if we have going this way, that's green. Going this way, it would be blue. This we don't know. It's blue or green. So this is also blue or green. This could be magenta going from here. This has to turn necessarily here. So this must turn. So this could go straight here. We have red and green for the yellow. They could connect. If oh, what happens if this goes straight? If this goes straight, this has to turn here because we need that to turn. So it goes independent. This would go straight. This can't connect to here, so this would have to connect that way, and then that way, and then that way. So that's okay so far. Um, hmm. Interesting. Um, so that's possible. Otherwise, it goes down here, which means that turns here, turns here. This is turning that way. Yellow is green with red. And then this would have to go I here necessarily. Hmm. So the next one, oops, the next one here is definitely red. So that's red with whichever one is there. This is cyan, which is blue or green. It could go straight through there. One of these turns. So obviously if this goes straight, if this goes straight here. Oh, how does that work? So say we had this going straight here. I guess it has to go like, so it has to go then something like that. This would have to turn here. This would have to turn here. This would be blue and blue. That could work. And then go straight there. So it would have to do something like that if it goes straight. That's fine. Uh, hmm. Okay. That seems fine. What happens if we turn then? If we turn, that's fine. Then this could go straight and then go some sort of blue here. So this is some sort of blue or green. This is some sort of blue or green. So the combinations for this I have to be either blue, green, or cyan. Okay. Um. Hmm. This seems fine also. Hmm. This is then has to go through here or this way. Obviously, if it goes this way, that's blue. So this has to be some combination of red here or blue. But this could also be blue coming in this way. Um, hmm. Uh, This has to go straight. This is going straight through here or here. That's interesting. It doesn't have to go through the green. Oh, this is interesting. So this has the same problem here as this quadruple here. So if we turned here and then turned here, this can't go straight through either way. Um, However, you could go turn here and turn there. Hmm. So this cannot be this and that. That's not allowed. And this can't be um this and that. So can it so hmm. If it goes straight here, it cannot turn here because then it would have to it can't go straight through, right? It has to go straight well, okay, so say it goes straight through here. You could do this, but then this can't be valid. And it can't turn here because it's not going straight through on when it's turning there. So if it goes this way, it has to go through that way then also. Okay. That seems fine. Um, what happens if it's not that way? So say it goes this way. This can't go here anymore because, again, it has the same problem. Well, hold up. It could go this way. That is potentially valid. Then this would have to go that way. Huh. Never mind. That is possible. Okay. Hmm. This one definitely cannot go this way because then that blocks all possibilities for this cell. I think I could do something like that. That's fine. Then this would have to go straight through there. This is fine. Also, then it could go either. This is kind of interesting. Hmm. Cyan, again, is blue or green, right? Yeah. So we have blue potentially here or green here on the cyan. Hmm. Mm. Hmm. 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 Okay. Okay, what happens if this is connecting these two? So let's try that. That means first I think this would have to be green. So we'd force this then to be green. This would have to be blue here, and this would have to be red here. Um, this cannot go straight through here, because again, that would have to connect to these two. This would connect that way, and then you'd have two edges here trying to connect to there. So this has to go that way, connect there. This has to turn here and go straight through there. So this would be green and red. So that could work. We'd have red and green giving us yellow, green and red giving us yellow, red and blue giving us magenta, and then this would be blue. Oh. Well, that's interesting. The problem then is this goes out here. How does this exit out? Either goes through the green when it's blue, which can't work, or it goes through this cell. But then this cell is not going to be going through a boundary here, through two pearls which are both green, right? So that's going to fail. Okay. So then this cannot go this way into here. Can't go red to cyan because that's blue and green. And can't go this way because then that forces a certain way that this works. Oh, well, actually, doesn't that in general mean that we cannot go this way? So say we tried going this way. We have the same problem either way, right? I guess this could connect to here. No. But then if it connects to here, we have the same problem. We have green either not getting to another pearl between here, or, yeah, blue trying to get into green. So this cannot go this way no matter what, which means this has to go straight. So this has to go straight through. It has to connect to here. This must go up here, connect to there to go straight through. And this is green and red that way. So we can we delete this? Yes. So then this is red. This can't be red. This can't be blue. Blue has to be here for the magenta, right? Blue and red make magenta. So this is blue. We have green and red here. This has to get green somewhere and then go green somewhere else. And it could be green going here and then going down here. Or it could be green coming from here and then going all the way around there. That is possible. This is blue, and this has to connect to this one. Because, so the, But it could connect this way, right? Oops. It could connect this way. We don't know. Or it connects this way. We don't know. But this one connects to here. Oops. We just don't know which way. So this cannot connect to here. It has to go... It can't connect to here. It could connect to this one here, right? That's fine. Green has to go from either... Okay, so... If this does connect this way, then this has to be blue. So then this green would have to be something funky like this going out. You technically could do something like that. That is possible. Interesting. So this cannot turn in now this way, right? Because if it goes here, it blocks. This has to go to two different ends, and this can't go out anywhere. So this has to come in from this way and then turn to one of these two. So this is going to be red or green here. So if it goes this way, then this is red. If it goes this way, it's red or green. We don't know. Either way, this has to go straight through then this way. And then it must turn. Oh, that's interesting. This is going to be blue or green. So this cannot go here. And then go to the magenta. Because this has to turn. So then if it goes here, it would connect to here. So what does this connect to? This can't connect to here because this must turn here after the white circle. And this has to definitely go through there. So this can only connect this way. So this has to go this way, straight through for the magenta. So this is blue. This cannot connect this way then, which means this can't go straight through here. It has to go straight through that way. And then therefore this turns. So this has to be blue, blue. Which means this is blue. And this has to be green connecting. So that's green. Interesting. Line has to continue this way. Line has to continue this way. Line has to go all the way around there. Right, because this can't connect to this. Actually, wait, that's not right. I mean, that could be right, but why can't this be green? Why can't that be green? So this we definitely know. But why can't that be green? Why can't it connect like this? And then go out? No. It could be, right? This could still be blue. Okay. Well, never mind. This is definitely blue, though. It has to go to a red, which could go here. Wait, but okay, so this has to exit out this way. It could connect this way, though. If that's green, green. Sorry, if this is not green, green. If this is blue going this way. We could turn here, so that's not anything there. This could go straight here. Hmm. So this could just turn here, and then that connects. That is possible. This could turn in here and then connect to green. But then that means this has to connect to here, which is possible. This would connect to here. Ah, we need a blue. So this cannot connect this way. So say this was connecting that way, and this is green, green. This is green or red. So none of them can connect this way. This can't turn this way because this... Yeah, how does this connect? It's not going to be able to get the blue. So this cannot can connect to this. This cannot connect to this. And this goes straight that way. So this has to be line going that way, which means this cannot go that... This can either go that way or that way. We need to connect to a blue here somewhere. So this has to go out this way. That's red, so this is definitely red. So this is red. This has to connect to a blue somewhere. It can't connect to here. It can't go through here, because then this doesn't have a connection. So this line has to connect out. It has to go out that way. So this one cannot connect to here, because if it connects to here, then this connects to there, and this would be a closed loop. So this must connect that way. Which means this is not... We have the green here, therefore this must be red and green to give us yellow. This connects this way, this has to connect this way then. So this has to connect this way, this must connect through here. And it has to connect through the label, because all the labels have to be connected through. Yep. So blue this is connecting this way, so this has to continue out. So this is green, which makes this blue. So this must be blue to form cyan. This green cannot connect to this one. So this has to be connecting through this green here. It can't go there, because then this doesn't go anywhere to connect to the green. So this has to go that way. This has to go back out here, and cannot... We're connecting to the green this, so this is green. So we have green here, and green must connect out somewhere here. Okay, so this is blue. This is blue. And if we try to connect to here, the problem is that this doesn't connect to the loop then anymore. So this must connect to here. So this is blue. Okay. So this is guaranteed to be blue. No blue here. This is green then. So this has to be green, which means the line does have to go all the way around here to avoid the blue. This line must go all the way here to connect. It turns here. So this is blue and blue. It must connect to that. This must turn that way then. And this could be blue and then red turning here. Or it could be blue and blue. And it would connect to that. So this cannot go straight. This is blue. Magenta's blue and red, so this cannot turn. So therefore it must go straight here, which means it's turning there. That means this has to extend out again. This cannot connect to this. So it has to avoid that. We could connect here to this blue. If we try to go this way, so we can't go through the M. So we either go this way or we go this way. If we go this way, this could go M and then that way. That is potentially possible. This has an I, and it cannot go through either of these, so this has to go through there. Obviously, it can't connect to both of these. It could connect to one, though. This is red and blue. So what is that? That's magenta. So we have magenta covered. And this is green with green or blue. So it's green or cyan. We're not sure. It's one of those two. Okay. This has to either go straight here and then turn, or straight here. And either way, this is going through. This one has to go through either here. Well, I guess technically it could go that. No, it can't go through the yellow. So it either connects here, or this is going here, which means it connects that way. Either way, this is green. So, oops. This is not pink. That's green. Hmm. Is there any way this is not red? Yes, the only way is it has to go that way, which means it connects there. Um, that would, well, you could connect that. No, you can't. Yeah, you could connect that way. Let's continue with this one. So this blue cannot go through magenta. What happens if it doesn't go this way? So it has to go that way then. It can't go through yellow, red, or red. It cannot do that because then this doesn't have a straight line to go through. So then it has to go that way. And then yeah, this magenta doesn't exit out anywhere. It has to go to here and then it can't connect to both. So that cannot go that way. So this has to go this way then. And then this way, and then it could connect. Obviously the magenta can't go straight through here. So this has to connect to this cell here, which means it's going straight there. So then it's turning here. This cannot be red, connecting there and there. This has to turn that way. This could then go straight through and then turn. Or it could turn that way. If it turns that way, though... Does this have to connect to this? I think the answer might be yes. If it doesn't, it goes straight here, which means it goes here. This has to go straight through. I guess it could connect that way. Eventually, it has to connect that way, I guess. So this is potentially possible. And then this goes this way, right? Oh, but we run into the same problem for the magenta here. This magenta can't go through red or yellow, so it's guaranteed to have to go through that way. Which means it's turning straight through there. So this is yellow, which is red and green. And this is magenta, which is red and blue. So this has to be the red. So this is red. And we have green going that way, and then this has to be blue to get magenta. Interesting. So this could... Okay, this does have to connect this way. Well, not necessarily. You could go straight through, go to magenta, and then you'd be stuck with yellow. Can this go this way? Answer is no. Because if it goes this way, these two cells, these two edges have to connect somewhere, and they're blocked by this. So this cannot go this way. It has to go straight that way. Oops. Then it turns. And if can it turn that way? If it turns that way, then this is blocked from having a line go straight through. So this has to turn that way. This can't go that way, so this has to turn that, has to go straight through that way. You could have this turn here and go magenta, or this goes this way and goes magenta. So I think either way, wait, this is, we already have magenta. So this cannot be magenta, magenta, so it can't go that way and go magenta. So this has to connect that way. It turns there, and it goes back down here. Wait, but this is red then, and this is blue. That fails. Shoot. This can't be magenta, magenta. Oof. No. Where's my logic here? That's wrong. I think all these other logic was correct, but maybe I messed something up here. Oof. Yeah, this can't turn. Because then that would be magenta, which forces that to be red, so that'd be blue, and that can't be blue and blue. Uh... Hmm. Hmm. Can't be yellow. Hmm. But the problem is that if... Shoot. Magenta has to go through, so it has to go that way. I guess it has to go that way then. And then magenta cannot go through any of these. It has to go that. I guess it has to go this way then. How did I eliminate that possibility? I don't know. I don't know. Anyways, this has to go this way and connect that way. So that's blue. So we have blue set also now. How did I eliminate that possibility? I don't know. Anyways, this is a blue-red combination of some sort. This is blue or red. I don't know how I eliminated that. Anyways. This obviously cannot go that way, cannot go this way. It has to go this way. This cannot connect because magenta's blue and red. So this has to go out this way. That means it connects that way. This cannot go straight here because that would form a loop by itself. So this has to turn there. This has to go straight through. This has to continue. That means this goes back this way. And this can only go this way. It can't connect to yellow line. So this must turn that way. And I think that's fine. This has to... This has to turn. And it cannot connect this way. It can't connect that way because that would block this loop from connecting, so it has to go that way. So then this has to go here, then here. This has to turn here because we don't have a turn immediately after. So this is between yellow and magenta. Yellow's green and red, right? So this is red. Red and blue is magenta, so that's blue. And this is some blue-red combination here. This has to turn. So we have line here. Yellow is red and green. We need a red for both of these, so this is red. So this is red, which makes this blue. So this is blue. Do we need to color the... It's just the pearls, right? Yeah. Okay. I cannot go through here, so I has to go this way. We have yellow going through here. That's red. That could connect to this red, and that would be fine. This either connects that way. This is yellow, so it's red and green. So what we cannot do, what we cannot do is go straight through here and then turn here. Whoops. Because this would be red and, actually I guess it could be green and blue. That is possible. What else do we have? So obviously this cannot turn here. It has to be going straight through here or turning there. So what happens if we go straight through here? It must turn in either here or this direction. But it could turn that way. Okay, let's see what happens if we do that. This is red, that would be green. if we turn this way, this would have to be blue. And the problem is this blue cannot connect to either of these, because if it connected to either of those, then this would be blue, and the eyes would not be all different. So it would have to either go here or go here. But this is a magenta here. So that would block that way. So it can't go there. It can't go here because it would connect to a red somewhere. So then it would have to go here. And then this would have two edges trying to exit out, and that does connect to the loop, and that doesn't work. So we cannot turn this way. We could still turn that way. Therefore, this can't go straight through here, which would mean that has to go that way. The problem with that, well, it could be red and red. Yeah, that could actually work. But the problem is this has to go somewhere, and it has to go through the blue. But then this has to go somewhere, and it has to go through the red. So either way, it just seems, you just cannot go straight this way. Because if it turns, this becomes blue, but then this is blocked. This can't connect to here. It can't go that way because then this magenta doesn't go anywhere. This cannot connect this way because this is cyan and this is magenta. So cyan could go that way, could go that way. But again, if we go here, blue cannot connect to any of these. Blue cannot go this way. Actually, maybe it could. So what happens if it goes there? This would have to connect that. This would then be a form of loop by itself, which is not allowed. That's the reason why. So then if we try to go that way, then this has to go that way. This would be blue and blue. This would be red going to nowhere. So that's not allowed. And if we try going this way, it doesn't have to go that far. You can go one there. This has to go that way, but then the problem is magenta touches here or one of these two, and that's not allowed. Actually, I think in general, we can't go this way, right? Because if we tried to go that way, I guess this could go this way. Huh. Okay. Either way, we just know that it cannot go straight through here. So then this must turn. This can't go straight that way. It has to go that way. Okay, so can you still have blue going that way? Not blue going this way. Maybe. You'd have red connecting out, having to connect out here, and this would be red. So that's possible. What about connecting this way, magenta? That means blue. How would blue exit out? This would have to go magenta here, but this would have to be blue, but it would connect to a red. So that's not possible. So this cannot go this way. It has to go this way then. So this is blue going straight through. This red has to essentially get out here, so this is red. So this is not that one. This cell's definitely red. So this cell's definitely blue here. And it cannot connect to the magenta here. If we go out here, again, we have the same problem in that you have two reds trying to get out one area, which is not possible. So this must connect to this way, so that's blue. This has to go out. It can't connect to itself, so it connect that way. So this has to go red, red, red. This has to turn. This has to turn. It can't turn to here, so this is turning that way. This cannot turn here because red and red don't make yellow, so that turns that way. This has to continue. It doesn't have to go that way. Could go this way and then go there. But what happens if it tries going this way? Then this is blocked off, so that does not work. So this cannot go straight through there because then this is blocked off, so this has to go that way. And it could go like that. So if it goes that way, then this would have to go that way, and that connects as this loop. So this cannot go that way. It has to go all the way around, connect here. This connects that way. So this is red and green here. So we have green here. This is red. This is blue and blue. So we have that's blue. That means this is red as a I. So we have red here. We don't know what this is. So this could be anything here. Cyan is green and blue. We already turned here, so that's fine. So we can go straight there. This is blue, so it cannot connect to this cell here. This line has to go straight through. So if we, well, we could technically. Um, um, hmm. We need a red and green eye. We need and then the one of them cyan and the other one's green. Um. This cannot connect. Well, it could. Okay, what happens if this connects to here? Can we go that way? This would then have to go here, and this would be blue. So couldn't it connect that way? Could it connect that way? Because that would force that to be blue, so it cannot go that way. So we could have blue going there. The thing is, we need 2 red circles here. Okay. What are other things we could do? What happens if we go that way? One thing is, where is this connecting to? This cannot connect to here because then this doesn't have anywhere to connect to. If we connect this to something else, then these would have to connect because this would be blocking that. And then, or this would connect to something else here, and this would connect to here, but then this would have to connect this way and to nothing. So this is always going to connect to here. So it's either going to be straight here or turning like that. Those are the only possibilities. Okay. In that case, this is always going to have to go through the cyan. Because if it doesn't go through the cyan, it's not going to be a. This cyan's not going to have any circle that anything that goes through it, right? So say we try to avoid that. This connects this way. Where is this connecting through? It can't, right? So this green is going to have to go through the cyan, which means it must go to a blue. Can it get through here? I think the answer to that is no. Right? Because so we're trying to avoid this circle. And the only way would have to go, well, we could technically go that way, but then again, you still have the same problem of this going that way, right? You can't connect this. This would be blue, trying to get a magenta out here. This would be red and blue there. So then if this connected, it's blue, but if this connects that way, it's blue. These two can't form a full loop. Because this would be blue and blue, so that can't connect. So this cyan has to essentially go through here. Because again, it can't go this way because then this is blocked from connecting to the loop. So it has to connect here. If we tried going that way through, then this connects to here, this connects to here, and this would not connect to the rest of the loop. So this has to go that way. Connecting to here, this is green. This has to be blue. So this is blue. This has to go out because it can't connect to any of these. This then must turn here, so that turns there, that turns there. That's fine. This could technically connect. We don't know. This has to turn, though. So we have to turn here and there. Red cannot connect to either of these, so red has to go out. We have to connect to a blue. We could just go out here. That is possible. Or we go this way. So obviously this cannot connect to itself. That would or connect here because that would form a loop by itself. So it either goes this way or it goes this way. If we go this way, the problem is this is red and blue to form magenta. Actually, I guess that could work. And then blue and blue. Huh. Hmm. What happens if we go that way? Then this has to be going that way. That means this goes down there. Hmm. Obviously, cyan could not connect. Huh. Okay, let's not get to that part yet. We do know this line has to continue out there. If this turns this way, this has to go down. But what happens if we connect that? If we connect that, obviously these can't connect, they're both blue. So this must go that way. That means this has to connect to here, so that goes that way, then turns. Um, so this would be magenta. This would... We cannot go this way, because then that would block this loop from connecting. So it would have to go that way. So then this would be blue. This would be blue, we don't know. Hmm. I mean, that seems like it's okay. Okay, what happens if we go down here then? So then this turns there. This must turn there. Obviously cannot connect still, so this goes straight through. This would have to turn, but it can't connect to here because this has to connect. So then this would be red. This would have to... Either way, I think this has to go that way. This has to go through this way. Actually, I guess it could exit out here potentially, but then that blocks that. No, so the answer is that can't go that way. So it has to connect to here somewhere. This is blue. This is red. Actually, this could connect that way. So this would be red here. This would be blue or green. The problem is we need a red and a red to connect to, right? So if we just connected straight here, the problem is we would have to have both of these be red. Where... I guess we could have a red coming from here, though. This is convoluted. We definitely have to go out that way. So most of the cases, we're going straight through here, right? What happens if we try to connect to here? We could have... Wait, this cannot... So this is still fine. This cannot connect to here because then that would force its own closed loop. So it goes to go there. Hmm. Okay, so if this line connects to the black, it obviously has to go that way. Because, well, does it? Maybe, maybe not. Yeah, it does. It does. Because if we do that, then this is magenta, but blue and blue don't form magenta, so it can't connect to that, and this is blocked. And you can't connect to itself because then that would be a form of closed loop there. So if it goes here, it has to go up. Otherwise, it avoids it. So either way, this is getting to here, period. So if we try to avoid it, then this has to go that way. This has to pick up the magenta to connect to there. This goes out this way, and it has to go there. This connects to here. So then this would be red. This would have to be red. So we'd have to have red here, red here. This would be blue or green. We don't know which. And this part has to connect to here. And it cannot go through cyan or red, so this would connect that way. This would have to get through cyan. But the problem is, how would these loops interact? This is red, so that can't go through cyan. You could have red going this way. Oh, but this would be blocked. Okay. So that's not possible. So again, if we try to avoid this, this has to go this way necessarily. This has to form that, and that would block this white cell from, or white pearl from actually working. So that cannot go that way. So this has to go through here. This has to connect to here and then connect to here. So that's the magenta that way. This needs access to a green and a blue as a possibility, and this needs access to red and red. Hmm. Well, okay, so can we ever get this as red? The problem, well, maybe. So we know this is red and that's blue. So we have blue here. We have no clue what this is. It could be... So it's either green, 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 blue, or green, red. Oh, so one of these is green. Green, 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 blue, or green, red. Okay. These both need to access a red. This needs to access a blue-green. This cannot access this one, because then this would block... Yeah, this cannot access this, because then these would be blue and blue trying to form a magenta segment, which is not going to work. So this must access a red. It could be the same red, but the problem with that... Well, this could technically be red, red. So, okay, if this accesses this... Oops. If this accesses this cell here, in some way. Or it goes like that. Okay, the problem is that doesn't work. So can't access it that way. So what about accessing it this way? So if it accessed that way, this would have to be going that way, going there. This would have to connect to here. It would have to form that. We'd have that's red. This would be cyan connecting to here. And then the problem is this would, one of them would have to go through, this would have to go through both red and cyan as both of these pearls, which is not going to work. So therefore, this cyan cannot connect to this. It has to connect to here. So then this is blue and green. We don't know. So blue and green here. We need a red and a red. So this cannot be red with, well, red could be here. So this is blue or green. We have blue or green here to form the cyan. This must access a red. And this must access a red. So the red has to be able to connect. If we go that way, the problem is this is not going to be able to exit out. Because it'll have to connect to here, which would then form a closed loop. So this has to go that way. That means this has to go that way. This has to connect to here because it can't connect to here because then that would be blocked from connecting. And this has to go, it can't go in here, so it can't go this way because then this can't connect to there. So this has to connect this way. These can't connect, so this has to go there. This has to go through the M. So then this is blue, that makes this red. That makes that red. Line has to continue out here. This has to continue out because it's blue or green. We have to have red here. It must connect to the red. It must connect to the red. This cyan has to come from here to here to here, so this is cyan. So this is cyan, so we already have a cyan here, which means this cannot be cyan, it's green. So this must be green and green. So this is green, not green here. That means this is blue. So since this is blue, this must be green here. And that's blue and green cyan, which means this is green and red here. And then I need to clean up some stuff. Yep, and that's the solution. Whew, that was kind of hairy, but kind of interesting. Yeah, a lot of interesting deductions there throughout. Definitely very hard, but maybe that's also because I'm not used to Masyu rules. As I've done a decent amount of Masyus, but I'm just not very. I don't have it as an intuitive grasp right now. So, but I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.